Ukraine's development and production of the Flamingo cruise missile marks a significant milestone in the country's domestic defense manufacturing efforts. The missile is reported to have a range of up to 3,000 kilometers and carries a warhead weighing approximately 1,000 to 1,150 kilograms, placing it among the longest range and most heavily armed systems currently attributed to Ukraine's arsenal. This development suggests a strategic ambition to gain the ability to strike critical infrastructure, command centers, military bases, and other high-value targets located far behind the lines of direct combat operations. The Flamingo missile is subsonic, reportedly cruising at speeds between 850 and 950 km per hour. It is believed to operate using a conventional jet propulsion system, likely a turbofan or turbojet engine. This would allow for sustained, efficient flight over long distances, but also makes the missile reliant on low-level terrain following or route planning to avoid air defenses, given that subsonic missiles are inherently more vulnerable to interception if detected. However, its long range allows it to be launched from locations deep within Ukraine, providing a buffer for the launch system itself and enabling flexible positioning based on strategic objectives. The missile is reportedly launched from a trailer-mounted rail system, likely designed to offer mobility and simplify deployment logistics. The use of a mobile launcher increases survivability and complicates enemy efforts to locate and neutralize the platform before it is used. Pre-launch preparation times are reportedly measured in tens of minutes, suggesting a relatively efficient operational tempo. While this may not allow for immediate use in fast-changing tactical scenarios, it is more than sufficient for planned strategic operations targeting fixed infrastructure or scheduled logistical routes. Regarding navigation and targeting, the Flamingo is said to use a combined guidance system that includes inertial navigation and satellite-based positioning. This dual-layer approach is consistent with modern cruise missile design and provides a backup in case of electronic warfare disruptions or GPS jamming. The system may also include terrain contour matching or other onboard sensors to refine accuracy over long distances, though this has not been confirmed. What has been suggested is that the system is designed to be resistant to electronic interference, indicating that efforts have been made to ensure the missile can still reach its target even in a contested electromagnetic environment. From an industrial perspective, the development of a cruise missile with these capabilities reflects a maturing domestic defense industry in Ukraine. Manufacturing such a weapon system requires advanced engineering capabilities, including aerodynamics, propulsion, materials engineering, guidance systems, warhead design, and systems integration. Serial production implies that the design has moved beyond prototype or testing phases and is being built in significant numbers for operational use. This represents not just a technical achievement, but also a logistical and organizational one, given the need to coordinate supply chains, quality control, and the integration of multiple complex systems into a unified weapon. There are strong indications that the Flamingo has been developed in cooperation or alignment with designs previously known under different names, such as the FP-5. This design similarity raises questions about shared technology, licensing, or international collaboration, but Ukraine has not publicly disclosed the full origin or development pathway of the missile. Regardless of these connections, the current production and claimed capabilities point to a system that is functionally Ukrainian, produced within the country, and deployed by its armed forces. Strategically, a cruise missile with a 3,000-kilometer range can reach targets far beyond the front lines. In terms of geography, this includes virtually all of the territory of the opposing state, as well as potential locations supporting military activity beyond immediate borders. The implications of this are profound, as it introduces a level of strategic deterrence and operational flexibility that few non-nuclear powers possess. It also signals to adversaries that key logistical and command nodes are no longer beyond reach, potentially affecting how resources and assets are positioned. The warhead size, estimated between 1,000 and 1,150 kilograms, makes the Flamingo capable of delivering high levels of destruction to hardened or fortified targets. Such payload capacity could be used against infrastructure such as airfields, fuel storage, transportation hubs, military-industrial facilities, or fixed radar installations. Depending on the design of the warhead, it could be optimized for blast, fragmentation, or penetration effects. The specific composition or modularity of the warhead has not been detailed, but the mass alone suggests a capacity for significant damage in a single strike. The decision to withhold many technical details is likely a deliberate strategy to maintain operational surprise and prevent adversaries from developing effective countermeasures too quickly. This kind of limited disclosure is common in active conflict environments where the performance of a new weapon system can be more effective if details about its operation, accuracy, or limitations are not fully known. It also reflects an effort to control the narrative and avoid premature assessment before the missile has been proven under real-world combat conditions. Although some unofficial sources have suggested that the Flamingo has already been used in operational strikes, there has been no full confirmation from official sources. Whether this is due to ongoing analysis, operational secrecy, or strategic ambiguity is unclear. It may also be the case that operational tests are being conducted without public announcement to evaluate real-world performance against live defenses and terrain conditions. In such cases, gathering data on range accuracy, survivability, and warhead effectiveness is critical for improving the missile and refining its deployment doctrine. The introduction of the Flamingo also has implications for how military operations may evolve going forward. Long-range missiles can shape battlefield dynamics by forcing adversaries to shift resources to rear-area defense, complicate logistics, and increase the vulnerability of supply chains and communications. They also offer a way to respond to attacks without immediately escalating to broader forms of conflict. In this context, the Flamingo may be viewed not only as a weapon of offense but also as a strategic signaling tool, demonstrating that Ukrainian forces possess the ability to strike back at distant locations with precision and force. In the longer term, the deployment of such a missile suggests that Ukraine is investing in a model of defense that emphasizes precision, range, and self-reliance. By building weapons systems capable of operating independently of foreign platforms or delivery systems, the country is enhancing its sovereignty in both military and political terms. This shift may also influence future planning, with a greater emphasis on research and development, long-range targeting intelligence, and missile defense integration. Overall, the Flamingo represents a significant technical and strategic development. While much remains unconfirmed or undisclosed, the available information points to a weapon system designed to project force far beyond the battlefield and contribute to a broader strategy of deterrence, disruption, and precision engagement. As more data becomes available over time, either through official disclosures or battlefield results, the full impact of the Flamingo on the ongoing conflict and future regional security dynamics will become clearer.